Hi there, this is a video for my grade 10 MIAP class. We're going to be taking a look at the second last lesson in our chapter 7 unit. And this lesson is called Properties of Systems of Linear Equations. And let me see if I can make that a little less blurry. That looks blurry to me. Well, that's even worse. Let's see if I can. Houston, we have a problem. Oh dear, that's no good. Come on, one more time. One more. There we go. Okay, so the first thing your notes are kind of missing is that what we're going to tell you about these things is actually true for a system of two linear equations in two variables. There are similar rules to this if you have systems of equations of three or more equations and variables, but we're going to focus here in grade 10 on two equations with two unknowns. What we can say is that a system of two linear equations in two variables can have, and this might surprise some of you, they can have one solution, they can have zero solutions, or they can have infinite solutions. That might sound strange, but you'll see why we can say that in a minute. First of all, let's one solution happens when the two lines, that's an E, sorry, have the different slopes. Right? If two lines have different slopes, they have to meet somewhere. For example, let's just do an example. Let's use the two equations 2x minus 3y equals 6 and 3x plus 2y equals 6. And let's just make sure we understand that those definitely have different slopes. Let's see if you can do it in your head, right? Change this to y equals mx plus b and tell me what the m is. So if I'm going to isolate for y, move the 2 to the other side, so it's a negative 2, but I'm dividing by a negative 3 to isolate y. So the slope here is 2/3. Okay, what would the slope of this guy be? Well, if it's 2/3, then these two lines never meet anywhere. But I'm pretty sure it isn't. When I move the 3x to the other side, it becomes a negative, and then it's a negative 3 divided by a positive 2, so this slope would be negative 3/2. Hey, not only are these slopes different, they're negative reciprocals of each other. Do you remember what that means? That's right, it means that those two lines are actually perpendicular, so they definitely meet somewhere. In fact, they meet each other at right angles. Now, what do these two equations look like? Well, let's see. Let's actually find the solution for that. Here, I'll do it on scrap paper. They don't give me a whole lot of room here. But let's do it on scrap paper. So on scrap paper, I have two equations. I have 2x minus 3y equals 6, and I have 3x plus 2y equals 6. Okay, how do I solve that system? Well, this is a minus, this is a plus. If I could make these two the same number and then just add the equations together, I mean the same coefficient, then they just cancel. So I'm going to times this equation by 2, and I'm going to times this equation by 3. This will work. So this is going to be 4x minus 6y equals 12. Don't forget to multiply the constant at the end. And then 3 times this equation is going to give me 9x plus 6y equals 18. When I add the two equations together, that cancels, which is what I wanted. So I get 13x equals 30. Right, because 9 and 4 is 13, and 12 and 18 is 30. So, ooh, that's not a very nice number to have to work with. 30/13ths, just to give me a decimal to estimate with here. 30 over 13 is going to be, I don't know, 1 point something? 2 point something. 2.308, roughly. So I'm going to say approximately, because of course decimals are approximations in this case. 2.308. And of course, I want the y value as well. Now, I don't want some approximate y value. I want the actual y value. So I'm going to go back to the fraction. So 4 times 30/13ths. Actually, why do 4? Let's go back to the original equation before I made it bigger by multiplying it. Let's go to 2x minus 3y equals 6. All right, what are you going to do with that? And this actually has something to do with the next lesson we're going to do. Well, if you're doing algebra and you have a fraction in it, you know what you can do is you can multiply the entire equation by the common denominator of that fraction, of all your fractions. In this case, of course, these denominators are just 1s. So the common denominator of 13 and 1 is 13. So I'm going to times this by 13, and this by 13, and this by 13. And that's going to cancel those 13s and give me 60 minus 39y equals, oh boy, what's 6 times 13? 60 and 18, 78? I hope that's right. And then I'm going to minus 60 from both sides, leaving me 18. And then I'm going to divide both sides by negative 39. So I get negative 18/39. I guess I better get a decimal for that too. So 18/39. What kind of decimal is that? Negative 0.462. So y is approximately negative 0.462. So I think that's my solution. So these two guys have a solution. Solution at, and let's see, what was it again? X was 2.308 and y was negative 0.462. There we go. So let's see, let's make a quick sketch of these two lines. Let's see. They have a slope of 2/3, which is positive, so the first line's going up, but its y-intercept would actually be down here somewhere. Like, you know, the y-intercept is, of course, the constant when I change to y equals mx plus b. So 6 divided by negative 3 is negative 2, so it would hit like at negative 2, so it would go something like this. And then this line would have a positive slope, because I can tell that because this number here would divide into the 6 to give me the y-intercept, which is going to be 3. So it's going to be, say, up there, and then they meet somewhere, somewhere down here. And when I say down there, I know that it's down there because remember, it's 2.3 over and negative, not quite a half down. So that looks about right. And there we go. And that is it. One solution for those two lines. It's kind of a nasty solution. You know what? Let's double check it. I actually kind of ran these through Desmos just to make sure I was going to do this right. So there's the first equation. Yeah, that's pretty close to what I sketched. And there's the second equation. And yep, there we go. They meet at 2.308 and negative 0.462. Just what I got. Awesome. Okay. Let's go back to our notes. There we go. What does it mean to have zero solutions? Well, you have zero solutions when the two lines are parallel. And do you remember how you can tell if two lines are parallel? It means they have the same slope. A good example of this would be, for example, I'll use the same first one. 2x minus 3y equals 6, which again was, I don't know, about there, something like that, right? Something like that. And then I'll have 2x minus 3y equals 1. So do you see how that's going to be different? This is going to have a y-intercept of negative 1/3. So that'd be, I don't know, like really close to here. But it has the exact same slope. It's going to still have, both of these are going to have slopes of, this is again a slope of 2/3. And this is also a slope of 2/3. Do the math if you don't believe me. And that means that these two lines will never, ever meet. They are parallel. Sorry if my drawing is a little off, but you can imagine that those are parallel. Let's double check that on Desmos. There is the first one, and there's the second one. And there you go. You could scale out forever. Wrong way. And it looks like they're going to meet, but they never will. If you zoomed in on a bigger scale, you'd see that there's always going to be space between those lines. So they will never ever meet, so they have zero. Let's go back to the notes. So they have zero solutions. Parallel lines never meet. So how on earth could they have infinite solutions? Well, let me give you an example. Let's first of all define it this way. It's when the two lines are, and the technical word for this in math is coincident. And then I spelt it wrong. There we go, coincident. Think about the word in the basic everyday English language, coincidence. What does it mean when something's a coincidence? Well, it means that, you know, two things happen that seem unlikely, but in fact, they're the same thing. So when the two lines are coincident, means this. Here's an example. Here's an example of two coincident lines. Again, I'll stick with the same first one. I'm fond of that equation here. 2x minus 3y equals 6. And then, for the next one, how about I'll give you one in y equals mx plus b form. Y equals 2/3 x minus 2. Now, those two equations look different, but they're actually not. For example, if I were to, again, change this equation into that form, the 2x would move to this side. It would become negative. You'd divide it by -3, and you'd get this. And then, of course, when you divided 6 by -3, you get -2. In other words, these two things they simplify to be the same equation. Now, why does that mean they have infinite solutions? Because what it means is that if I graph the first line, I get this, and if I graph the second line, I get this again. So there's an infinite number of points that satisfy this equation and that equation. So you can kind of say it's like there's infinite solutions to this system of equations because every single point on this line fits them both. They're all solutions. I know, most people go, that kind of is cheesy. I mean, really, it's the same equation twice. And Desmos understands that very well. Again, here's the first equation, and then here's the second, and watch what happens to the line. Right? It's green, it's red. It's green, it's red. It's the same line in both cases. So every single point all the way along the red line is the same as every single point along the green line. Cool, huh? So there you go. The technical name for it is those two lines are coincident, which basically means they're exactly the same line. You don't necessarily have to see the two lines as being in different forms either. You know, a good example too, I'm going to just show you again, this is some scrap paper. Here's another example of two lines that look kind of different, but they would in fact be coincident. Do you get why those two lines would be in fact exactly the same line? Let's type it into Desmos and see. So if I've done this right, I should not get a different line when I type in 4x minus 6y equals 12. There it is. It's black, it's green, it's red. It's the same line. How come? Can you see why these two lines are the same? All right, do you see it? It's because if I divided each part of this equation by 2, or I times each part of this equation by 2, they would in fact be exactly the same equation. So we call those coincident systems, and it means that you're not solving for anything specific. It means that any point on one of them is also a point on the other. So, example number 1. How many solutions do you think this system of equations has? Well, all you really have to do is prove that they don't have the same slope, and then you can say that it's 1. So I'm going to change this to y equals -x plus 3. So the slope is -1. I'm going to change this one to -y equals 2x minus 2 by adding 2x to both sides. Then I'm going to divide both sides by -1. And there we go. This slope is -2. Therefore, one solution because they have different slopes. It didn't say it wanted me to solve the two equations, it just wanted me to say how many solutions it has. Okay, so that was example 1. Example 2, determine the number of solutions for the following system of linear equations. Okay, determine the number of solutions. So, once again, I think I am going to let's see, you know what, I have a different idea this time. You know what? What I noticed looking at this one is that if I multiply this equation in all three parts of it, all three terms, by -2, look what happens. I get positive 4x, I get positive 6y, and I get -10. Therefore, infinite solutions, and I just started spelling the word infinite when I wanted the word solutions. Infinite solutions, and the reason why is because the two equations are the same. Okay. And then example number 3, how many solutions do you think that has? Well, let's see. Is there a quick and easy way I could prove one equation is the same as the other? No. So I think, again, I got to look at their slopes. So let's take a look at the slope for this guy. Minus 4y is equal to -2x minus 1. Divide everybody by -4, and I get 2/4 x plus 1/4. Now I can't do anything with 1/4, but I can simplify 2/4 to a half. There we go. So the slope of this line is 1/2, rise of 1, run of 2. Let's do the other one now. This one is -6y equals -3x plus 2. Divide both sides of the equation by -6. And I get 3 over 6, the negatives cancel, minus 2/6. And this one, now, this is important, and I should have done this over here where I have more room, but I'm going to just squeeze it in here. My apologies. That's 3/6 is also 1/2, so look at that. They have the same slope, but wait a minute. They have the same slope. How do I know they're not exactly the same equation like this? Before I finish that off, can you tell that they are in fact going to be different equations? How do you know they're going to be different equations and not exactly the same equation like they were up there? Can you see it? It's because this simplifies down to 1/3. And remember that in this form, that's my y-intercept, right? That's b. And that's my y-intercept. And so therefore, no solutions. And the reason why is because the lines are parallel. And how do I know they're parallel? Because they have the same slope, but different y-intercepts. Okay, this is fun. Let's work backwards. Suppose I give you an equation, and then I ask you to make up an equation that when I combine it with this, I have only one solution, exactly one solution. In other words, an equation that's different than this. This is easy. All I got to do is just make any number here that isn't 6. So put anything you want here, any number not equal to 6. You give it 1, 2, 4, a billion, whatever you like, and those two lines have to meet someplace. No solution. How do I make an equation like this one, but there's no solution? So that means it has to have the same slope, but this has to be any number but 3. Do you get why it couldn't be 3? Because if it was 3, it'd be the same line as this, and then there's infinite solutions because the two lines meet everywhere. So this could be any number not equal to 3. Now, this is the tough one. How do I make it so that this has an infinite number of solutions? Well, you could just write, well, I'll just write the same equation again. But no, I want it to look different. So what I think I'll do is, how about I will times everybody by 2. There we go. That looks different, especially if let's put it into standard form. So 12x minus 2y, sorry, general form. I keep forgetting that your textbook calls it general form. There we go. There. That totally looks different than that, but they're the same equation exactly. All right, that makes sense? So that's really all there is to 7.6. But this isn't an actual chapter in the book, but what we've done so far is we've kind of skipped assigning you word problems to solve. So we're going to set up and solve some word problems, and then we're going to do a blast from the past. We're going to go back to the first notes we did in this chapter. All right, example 1. Set up and solve the following linear system. Two numbers have a sum of 40 and a difference of 6. Determine the two numbers. Okay, so I'm going to sharpen my pencil before I do this here. Now, let's see. This is interesting. Two numbers. I will let those two numbers, let x and y be the two numbers. So one of them is x and one of them is y. Now, two numbers have a sum of 40. What does sum mean? It means they add to make 40. So x plus y is equal to 40. They have a difference of 6. What does difference mean? Difference is a subtraction. So x minus y is equal to 6. There's my two equations and my two unknowns. And this is totally set up for elimination, because if I add these two equations together, I get 2x equals 46. X is equal to 23. And so if x is 23, 23 plus y is equal to 40. Move the 23 to the other side, and I get 17. Therefore, the numbers are 23 and 17. Yes, this statement has to be part of your answer. This is the easiest half mark you're ever going to get from me, but if you don't do it, you lose half a mark when I assess you. Okay? Same with this. You have to define your variables so that the person looking at your work knows what you're solving for. Okay? So again, so that's a half mark, that's a half mark. 1 mark just for doing those two things. That's the easiest mark you're ever getting from me. But it is a mark. It has to be done. Word problems can't just be a bunch of work or just an answer. And no, you can't go, oh, I could have figured out that it was 23 and 17 just by guessing and checking. Guess what that's going to get you on the test if you do that? A big fat 0. Because we are trying to test that you can think algebraically. I could care less what the solution to this problem is. I could care less what these two numbers are. I want to see that you can think algebraically. That's what we're going for here. You have to come up with equations. You have to solve the equations. The equations have to make sense in the context of the problem. Okay. Sorry to be a meanie about that, but I'm here to teach you algebra. And let's talk about McDonald's. At McDonald's, 2 cheeseburgers and 1 large fries have 1,100 calories. 1 cheeseburger has 200 fewer calories than 1 large fries. Okay, how many calories are in 1 cheeseburger and how many calories are in 1 large fries? Okay, so I'm going to let x equal the number. Before that was a hashtag, that was a symbol that meant number. Number of calories in 1 cheeseburger. And I will let y equal the number of calories in 1 large fries. I wonder if anybody actually did research to see if these numbers are accurate. If anybody works at McDonald's, check that out for me. Okay, let's look at that. Can you come up with the equations? How about you pause the video for a sec while I take a sip of my beverage here and see if you can come up with the equations yourself. Because we did stuff like this back in 7.1. So try it yourself. Pause the video. Did you get it? Let's see. 2 cheeseburgers and 1 large fries. So the number of calories in a cheeseburger is x. So 2x, 2 cheeseburgers, add 1 large fries is equal to 1,110. No, sorry, 1,100, sorry. 1 cheeseburger has 200 fewer than a large fries. So the cheeseburger is smaller than the fries. So to make the cheeseburger equal to the fries, I am going to have to add 200 to the cheeseburger. Get it? Now you could have done this the same way as me, but put minus 200 on this side and left the x by itself. It would have been the same thing. You could have said cheeseburger is y minus 200. But I like doing it this way. Okay, so do you get what we just did? We totally set this up for substitution because y is x plus 200. So I'm going to substitute that in here. 2x plus, and instead of y, I'm going to put x plus 200, the substitution method. And then 3x plus 200 is equal to 1,100. I'm going to minus 200 from both sides. 3x is equal to 900. Divide both sides by 3, and x is 300. Go back over to here. Y is equal to 300x plus 200. And then therefore, my conclusion statement, if anybody didn't know that, 3 dots means therefore like that. Therefore, 1 cheeseburger has 300 calories. I'll just put CAL for calories. And 1 large fries has 500 calories. And there we go. Using algebra to solve word problems like grown-ups. That's awesome. Love this stuff. Okay, 1 more of these, and then we're going to go back in time. Blast from the past. Let me get this nice and organized here. Paras has a total of 30 $10 bills and $5 bills. So 30 $10 bills and $5. He's got 30 pieces of paper. He doesn't know how many of each because apparently he can't count, but he can do math. This is an interesting problem. If the total value of the money Paras has is $200, how many of each type of bill does he have? Okay, so let x equal number of $5 bills that Paras has. Let y equal the number of $10 bills that Paras has. He has 30 pieces of paper, so the number of x's plus the number of y's is 30. But their value is 200. Ooh, this is interesting. So their value is 200. So that means every $5 bill you have is worth $5, right? So if you have 1, that's $5. You have 2, that's $10. If you have 3, that's 15. So this number times 5 is how much that's worth. And this number times 10 is how much those are worth. And I know together they're worth $200. All right. How you feeling about this? And you want to do substitution? Me neither. I'm going to do elimination. I'm going to times the top equation by -5. So that's going to be -5x's minus 5y's is equal to, what the heck is 530s? 150, but it's negative 150. And then I'm going to add this equation to this one. Hopefully you've done lots of practice on this if you've been doing your homework, because I assigned a good, I don't know, 15, 20 of this type of thing to do if you did the homework. So this plus this is nothing. -5 of these plus 10 of these is 5. And 200 plus -150 is 50. Okay, and then 50 divided by 5 is 10. And then go back to this equation because it's simpler. X plus 10 is equal to 30 by substitution, so x is equal to 20. Therefore, Paras has 20 $5 bills and 10 $10 bills. And you can do a quick check on this. So I didn't bother checking the last one, but you can do a quick check. Here, 20 times 5 is 100, and 10 times 10 is 100, and 100 plus 100 is 200. It works. So there we have it. Let's go back in time. If you flip to the beginning of your booklet or to wherever you did the notes for 7.1, there they are. We're going to come back and do the last part of this as another lesson. Remember I told you to put a star by this because we would come back and solve these someday? Well, someday is here, everybody. Let's solve these 3 equations now that we know how to do it. And my computer's making beeping sounds. Ignore that. So let's see. I could use a piece of scrap paper or something. I think I have some under here. There we go. All right. So let's do example 1. So they had X small buses, Y large buses. The small buses held 12 students. The large buses held 24. And altogether they could move 780 students. And the large buses have 20 more kids than the small buses. And no, that's not what that means. They have 20 more small buses than there are large buses. That's what it is. So that's to make the two things equal, you have to add 20 to the number of large buses. I'm very sure we did that right. Okay, that's totally set up for substitution. So let's substitute. So that's going to be 12 times, and instead of x, I have 20 plus y, plus 24y equals 780. So that's going to be, oh boy, what's 12 times 20? 24 with a 0, plus 12y, plus 24y is equal to 780. So 240 plus 36y is equal to 780. 780 minus 240 is going to be 540. Gee, I hope 540 divides by 36. I can't have decimals of buses. How could you have 0.5 of a bus? Oh, I don't. That's 15 exactly. So 15, and then go back to maybe up here. So x is equal to 20 plus 15. So x is equal to 35. Therefore, I will say therefore, they have 35 small and 15 large buses. All right, so there's the first one. Let's do the second one. Length is L, W is width, and perimeter is 2 lengths plus 2 widths, and that's 158. And I know that the width is 31 less than the length. So the width and the length would equal each other if you took 31 away from the length. Once again, I think we're totally set up for substitution. So 2 L's plus, instead of 2 W's, 2 L minus 31s. That's an L, not a B. Is equal to 158. So let's see, that's 2L plus 2 times L is 2L. 2 times negative 31 is negative 62. It's equal to 158. I'd add 62 to both sides and collect those as like terms. So 4L is equal to, let's see, add 2 to 58 and you get 60. 160 plus 60 more is 220. Somebody better double check my mental math on that. 60, yeah, I think so. So L is equal to 220. 4 goes into 250 times and then 25 times. So I think that's 55. Sounds good. So L is 55, which means that W is 55 minus 31. So that would be 55 minus 31 is 24. So therefore, rectangle is 55 feet by 24 feet. Okay, so there's 2 up, 2 down. Let's look at number 3 here. I'm going to just move this down a bit. There we go. A school raised $140 by collecting 2,000 cans and bottles. So, cans plus bottles is 2,000. And if you get 5 cents for every can plus 10 cents for every bottle, you get $140, which is 14,000 cents. So I think I'm going to do this one by elimination. So I'm going to times both sides of this equation by -5. So I have -5c minus 5b is equal to negative, okay, 5 2's is a 10, and then there's 3 more zeros on it. And I'm adding this equation to this equation. 5c plus 10b is equal to 14,000. So -5 plus 5 is nothing. That's why we did it. -5 plus 10 is 5. And 10,000 minus 14,000, or 14,000 minus 10,000, is 4,000. And 4,000 divided by 5 is 800. And then go back up here. 800 plus, or sorry, c plus 800 is 2,000. So c plus 800 is 2,000. And so c is equal to, what would that be, 1,200? So therefore, they collected 1,200 cans and 800 bottles. And you guys are now ready to try some homework where you actually do some word problems. Fun, fun, fun. Okay, see you later.